Leap years. They can be confusing. Once every 4 years, an extra day is thrown into the calendar, and your friend who didn't have a birthday the previous 3 years now gets the chance to celebrate. And then we'll have to wait another 4 years to celebrate once again. Before we dive into the topic, let's look at the history of leap years. A couple thousand years ago, the Romans realized that it took slightly longer than 365 days for the Earth to make one complete lap around the Sun. To account for this, in 46 BC, Julius Caesar decided to create a calendar which added 1 day every 4 years. Today, we call this the Julian calendar, and you might be thinking, this is what we use today. Well, not quite. By 1582, the equinoxes and solstices were occurring 10 days earlier than intended. As a result, Pope Gregory decided to skip from Thursday, October 4th to Friday, October 15th, cutting out 10 days in the calendar. You see, it was determined that it actually takes 365.2422 days for Earth to orbit the Sun, slightly faster than the 365 and a quarter that Caesar came up with. Going forward, leap years would be held every 4 years, but not every 100 years, but yes, every 400 years. This new calendar is called the Gregorian calendar, which is what we use today. This is why 1600 and 2000 were leap years, but not 1700, 1800, and 1900 were not. If leap years are the exception, then 1700, 1800, and 1900 were the exception to the exception, and 1600 and 2000 were the exception to the exception to the exception. Confused? Good. Leap years also throw a wrench into the pattern of our calendar. There are 365 days in a year and 7 days in a week. This means there are 52 weeks and 1 day in a year. That means that a date on the calendar will fall on the next day of the week the following year. Well, that's not always the case. In leap years, there are 366 days in a year, meaning 52 weeks and 2 days in a leap year, which means that sometimes a date on the calendar will fall 2 days of the week later the following year. For example, Christmas fell on a Tuesday in 2018 and a Wednesday in 2019, but fell on a Friday in 2020 since that was a leap year. However, this isn't always the case. The leap day is not at the start or the end of the year. It's February 29th, the end of the second month of the year. This used to be the end of the year in some lunar calendars before Caesar, but that's another topic for another time. Using the pattern we just talked about, let's look at a different example, Valentine's Day. It fell on a Wednesday in 2018, Thursday in 2019, and Friday in 2020. The day we all know and love did not jump ahead 2 days in the week like Christmas did, since Valentine's Day is February 14th, 2 weeks before the leap day. Valentine's Day did jump ahead 2 days in 2021, falling on a Sunday that year. Even though 2021 was not a leap year, the first 2 months of the year after a leap year are subject to the same rules as the last 10 months of a leap year when it comes to this pattern. If there were no leap years, a date would fall on the same day of the week every 7 years. However, since there are leap years, a date will fall on the same day of the week every 6 years most of the time. For example, the last 10 months of 2004 and 2010 were identical. 2005 and 2011 had the exact same calendar. The first 2 months of 2006 and 2012 had the same calendar. Sometimes there are 2 leap years in a 6-year time span, which throws yet another wrench into this pattern of the calendar. For example, the first 2 months of 2004 and 2009 were also identical. This is because there were 2 leap days in between then, February 29th, 2004 and 2008. As a result, the last 10 months of 2003 and 2008 were also identical. However, back to using Valentine's Day as an example, it fell on a Friday in 2003, but did not fall on a Friday again until 2014. The 6 years later rule of thumb does not work here, because although 2009 was not a leap year, it was in the first 2 months of the year after 2008, a leap year. The secondary 5 years later rule of thumb does not work here either, since there was only 1 leap day in between then. In summary, to determine when a date will fall on that same day of the week in the future, use this complicated trick. If there is only 1 leap day between now and 6 years from now, that date will fall on the same day of the week in 6 years. But if there are 2 leap days in between now and 6 years from now, that date will fall on the same day of the week in 5 years. But If that date 5 years later is within 365 days before a leap day, you will have to wait 11 years for that date to fall on the same day of the week. This is a long way of saying that a date is guaranteed to fall on the same day of the week every 11 years, unless both dates are within 365 days of a leap day.